Okay, so today we're going to be covering 8.2, understanding standard deviation. In the last lesson, we talked about what standard deviation was and how it measures spread of data, how far from the mean data the data goes. And so you can see here that standard deviation will always be a positive number. How it's calculated varies slightly depending on whether the standard deviation is describing numbers from a population or from a sample. Because most instances of standard deviation describe samples, we will focus on the sample formula as we did in notes 8.1 with Desmos. Recall that the variable for sample standard deviation is the lowercase s. So now, it says here, use the table below to determine the standard deviation for this data set, 66283, okay? So the first thing that you're going to need to do is calculate the mean. So to calculate the mean, I'm going to do this over here. And I have x bar, right, is equal to, and you guys know to calculate the mean, you add the numbers together. So 6 plus 2 plus 8 plus 3. And you can see that you have 5 numbers here, so we'll divide by 5. And when you add those numbers together, you get 25 over 5. So the average is 5. Are we okay with that? Okay, now I'm going to start filling in this table, and the table is actually cool. This is such a great way of organizing the information. So the first thing that I would like to do is I'm going to take these numbers right here, and I'm going to put this in the x sub I column. Okay? Now, x sub I, don't let it freak you out. The I is just a subscript. It's a name. The I is basically just going to represent the position of the numbers, right? So this first one, I'll write it out here, but we don't normally write this. This is going to be x1. This will be x2. This will be x3. Do you get the idea? So the I is just representing which position we are in this list. And so you can see that I'm going to put, the 6 is the first one, right? And then the 6, the 2, the 8, and the 3. Now, what I have written here in the pencil off to the side, you guys don't need that, but just so you can see, well, what does that I actually represent? Are we okay with that? Okay, good. Then I'm going to take the next column is going to be the average. Well, we just calculated the average right here, so that's going to go in this column here, and you're just going to write the 5 times. Okay. Now the next column, you're going to do xi minus x bar, right? Xi minus the average. So you're just going to subtract those two. 6 minus 5 is 1. 6 minus 5, 1. 2 minus 5, that's negative 3. 8 minus 5, that's positive 3. 3 minus 5 is negative 2. Got it? So what's the difference between this column here, xi minus x bar, and this one? You're squaring it. So all you're going to do is you're going to take this column here, and you're going to square each of those. 1 squared is 1. 1 squared, 1. Negative 3 squared, 9. 3 squared, 9. Negative 2 squared, 4. Are we together with the chart? Okay, then there's just a few things that we're going to do here outside of the chart. First thing that we need to do is we need to add these together. 1 plus 1 plus 9 plus 9 plus 4. That's going to be 24. Okay, are we okay with that? Okay, so now what I'm going to take the 24 here, and I'm going to move it up here, and I'm going to divide by n minus 1. Divide by n minus 1. Okay, what's n? N is the number of terms. So I'm going to take that 24, and I'm going to divide it. I'm just going to put a little line here just to show that this is different work. So 24, and we're going to divide by the number of terms. Well, how many terms are there? 1, 2, 3, 4, 5, right? So it's going to be 5, and then subtract 1. So that's going to be 24 divided by 4, which is 6. Are you okay with that step? Okay. And then the next step, you're going to square root. So it's going to become, so then I'll put here, the standard deviation is going to be the square root of 6, which means that the standard deviation is approximately, and when I put the square root of 6 on my calculator, I get 2.46. I'm going to do this. Now, remember, well, what does that mean, right? So I'm going to take this information and I'll say here, so therefore, right, with this information that I have, the typical number is within, I'll use the symbol, is within 2.46 of the mean, which the mean was 5. So that means if I take 5, right, and I add or subtract, actually here we should do this. Let's first write it mathematically here with symbols. So if I take the mean, I'm going to add or subtract the standard deviation. So in this case, it would be 5 plus or minus the 2.46. So if I subtract 5 minus 2.46, that's 2.54. And here, if I add, that's 7.46. So that means that most of the numbers fall between 2.54 and 7.46. And that you can see that that's the case, right? We did have a number below, right, and a number above, but most of the numbers in there did fall between. Okay, how are we doing? Standard deviation, not too bad. Just steps, right? You got to get the steps down. All right, let's bump down here. Now we're going to consider 2 more data sets. We have data set X, 2, 4, 3, 4, 5, 3, and data set Y, 3, 2, 3, 10, 5, 4. It says calculate the means for data set X and Y. So I'm going to calculate the mean here. And so the mean for X is going to be 2 plus 4 plus 3 plus 4 plus 5 plus 3. And then that's all divided by, and there's 1, 2, 3, 4, 5, 6 numbers. When I add those together, I'm going to get 21 over 6. And so then you can see that X bar is going to be 21 divided by 6. I'll just tell you is 3.2. 5. Are we okay with that? Let's do it for data set Y now. So I'm going to take and add 3 plus 2 plus 3 plus 10 plus 5 plus 4. I'm going to divide that by the total number of numbers, which is 6. When I add those together, I get 27 divided by 6. So when you divide those, 27 divided by 6 is 4.5. All right, now it says draw parallel dot plots of the two data sets. Use the same scale for both plots. So, and then you can see here, I have a number line. So my way of doing the parallel is I'll do X on the top and Y on the bottom, right below. So I'll do X's data here. I'll do Y's data down there. And so let's do the dot plots. And I think, let me get, I can use this one. Yeah, we'll use this one. Okay. So let's put the numbers on so you can see. For X, you have a 2, so I'll put a dot at 2. And then I have a 4, so I'll put a dot at 4. I'll do a dot at 3. I'll do a second dot at 4. I'll do a dot at 5. And then a dot at 3. Now, what I would like to do is, oh, I need to put the other one on, don't I? So the other one is 3. So I'll put a dot here at 3. And then 2. And then 3 again. 10, way over here. A 5. And a 4. Are we okay with that? Okay. So then part C says, for each dot plot, draw a vertical line at the mean, then represent the deviations from the mean as horizontal line segments. Okay, so I'm going to put the mean in. I'm going to bring this back down and just kind of focus on this. This is what they're asking us to do. So the mean for X was 3.5. So I'm going to, this is about 3.5 here. Do you agree? And then I'm going to just draw a vertical line as high up as I can go here. And then for Y, it was at 4.5. So I'm going to put 4.5 here, and then I'm going to draw a line going all the way down here. Okay, are we good with that? Okay, so I'm going to show now the deviations. I'm going to draw a line just showing how it's spread out. And so going, the first is the 2. So I'm just going to go in the order that they're listed there. So 2, right, looks something like that. And 4, I'll just go down just a little bit, and that's just like this. And then 3, that's going to be here. And then 4, again, that goes about here. 5, that's going to go all the way over here. Not all the way, not that far. And then 3 again. Are we okay with that? Yeah? Okay. And then for the second one, right, I'm just going to go in order, right? The first one is a 3. and then a 2, then a 3 again, a 10, a 5, and then a 4. Okay, I'm going to put that up here. There we are. So that's what they were asking for in C. Are you guys cool with that? Doesn't it give you kind of a nice visual of like how far it deviates from the mean? So then the next question says, okay, based on your plots in part B, which data set do you think has the larger standard deviation? Explain your reasoning. So what do you guys think? Which one do you think has the larger deviation? And why? Okay. Student says why. I would agree with that. Why did you pick why? Okay, it has really long 10, right? But you have to base it on all the deviations. But doesn't it look like all the deviations, right, are longer here, right, or bigger, as opposed to the orange ones up above? Do you guys see that? Okay, so let me just take this off and let's, I'm going to say the lines representing the deviations. From the mean, right, the deviations from the mean are longer in y than x. So deviations from the mean are longer in y than x. Okay, that was kind of a cool little activity, so you get an idea, right? The deviations, right? Standard deviation. What is the standard deviation? So what is that general spread, right, from the mean, how far it goes? Okay, calculate the standard deviation for x and y. Should be a capital X here. And y. Round your answers to the nearest hundredth. Do your calculations. Confirm your answers in part D. So I am going to take the data here, right? The 2, 4, 3, 4, and 3. I'm going to put it in this one, and I'll do the same thing with this here. Oh, I just realized that when I made this chart, I actually didn't make it big enough. So let me just, I'm going to extend this just down here a little bit so I can put the 6th piece of data in, because I cut and pasted from the previous one and I only have 5 pieces of data. Okay, so taking the data, right, x sub I is each piece, so it's the 2, the 4, the 3, the 4, the 5, and then the 3. And then for this one, it's 3, 2, 3, 10, 5, 4. All right, let's just focus on the first one now. So now we need the average for set x, right? So the average for set x, didn't we find that already? Right, in part A, we had that it was 3.5. And then for y, it's 4.5. I might as well put those in. So this one was 3.5 here. This one's 4.5. So these are going to be all the same going down. And now I'm going to subtract those. I'll just tell you. So 2 minus 3.5 is negative 1.5. 4 minus 3.5 is 0.5. 3 minus 3.5 is negative 0.5. 4 minus 3.5 is 0.5. And then 5 minus 3.5 is 1.5. 3 minus 3.5, 3 minus 3.5, that's negative 0.5. And then remember, you have to square each one of those. So this is going to be, I'll just tell you, it's 2.25 when you square negative 1.5. This is 0.25. This is 0.25. This one's 0.25. And then 1.5, that's 2.25. And then this is 0.25. I'm just going to write here from to A. I'll do the same thing here. Okay, and then if you remember correctly, you're going to add that final column together. So in this case, we're going to get that 5.50. So then the next step here is you're going to divide by n minus 1. So it's going to be 5.50 divided by, and then there were 6 numbers. So it's 6 minus 1, which is 5.50 divided by 5, which is equal to 1.1. And then the last step, square root. Thank you for letting me know that you can't see. There we go. I'm so sorry. So you can see I took the 5.05, I divided by n minus 1. N was 6 because there's 6 numbers. So that's 5.5 divided by 5, which is equal to 1.1. And now I'm going to do the square root. So, and the letter we use is lowercase s, is going to be the square root of 1.1. And when you square root that, you're going to get approximately 1.05. Let's do the second one. So I'm going to just bring this down for every single one. 4.5, 4.5, right? This is the average that we took from problem 2, part A. Just looking above. I'm going to subtract those. 3 minus 4.5, that's negative 1.5. 2 minus 4.5 is negative 2.5. 3 minus 4.5 is negative 1.5. 10 minus 4.5 is 5.5. 5 minus 4.5 is 0.5. And then 4 minus 4.5 is negative 0.5. I'll square each of those. I'm just going to tell you the result of squaring. 2.25. Negative 2.5 squared is 6.25. Negative 1.5 is 2.25. 5.5 squared, I'll tell you, is 30.25. 0.5 is 0.25. And then negative 0.25 is 0.25. Okay, I'm going to add those together. That's 41.50. We can already see it's already so much bigger than x's. So here we're going to divide by n minus 1. So this is going to be 41.50 divided by 6 minus 1, because there's 6 numbers, so that's n is the number of numbers. So this is going to give me 41.50 divided by 5, which is 8.3. And then if you remember correctly here, we're going to square root. So I'm going to get S is the square root of 8.3. S is approximately, when you do the calculation, 2.88. So the typical number, right, will be within 2.88 of the mean, which in this case was 4.5. The typical number for this one will be within 1.05 of its mean, which was 3.5. Okay, just it's really just one more page and then there's practice problems, but we're not going to do the practice problems. I'll leave that in your notes so that you can practice them and do them. Can we move to this? Comparing standard deviation. So below you'll find 3 pairs of graphs. The mean for each is mu, right? That looks like a fancy M. Mu is a Greek letter. So the mean for each graph, mu, is given just above each histogram. For each pair of graphs presented, indicate which one of the graphs has a larger standard deviation, or if the 2 graphs have the same standard deviation, and explain why. So for this one here, we're looking at these two. The standard deviation, the mean for this one is 1.93, and the mean for this one is 2. So which one do you think has a larger standard deviation? Now this is frequency, how often numbers occur, right? So that would mean that there would be, 6 numbers between 1 and 2. Got it? This would mean that there is 1 number between 0 and 1. Is that helpful? So looking at the spread of these two, what would you say? Which one has the larger standard deviation? Well, think about the mean, right? The mean in each one. So the mean for the first one is 1.93. So it's about here, isn't it? And the mean for this one is 2, so it's about here, right? Where do most of the numbers occur for this mean? Doesn't it look like it occurs pretty close? With the exception of the frequency of these 3 numbers over here, right? They're actually fairly close to the mean, aren't they? Notice this one, it's 2, right? Notice that most of the numbers are happening on the extremes, far away from the mean, further away from the mean, at least. Do you see that? So because this one has a lot of numbers that occur a distance from the mean, this will have the larger standard deviation. Is that clear? So let's write that in. So most of the data in set B is at the extremes. So the extremes here are the numbers between 0 and 1 and 4 and 5. I'll just say 0 and 5. In set A, a larger portion of the data is around the mean. So because of that, I would say that B has the larger standard deviation? Does that make sense? Okay. Let's take a look at number 4. The average for the first one is 5.33, so it's about here, right? And for this one is 5.48. It's about here, right? Which one in this case would you say has the larger standard deviation or the more spread? A. Would you guys agree? Why would you say A? The more what? Sorry? The extremes has more frequency. Okay. You can see that the extremes are going lower as you go further away from the mean, but here they're actually getting, it looks like they're getting larger as you get away from the mean, right? So I'll say most of the data in B, in set B, so I'll see here, is around the mean. I'm going to be a little more specific just to kind of help as you're doing your homework. As we get further away from the mean in set B, the proportion of data decreases. Right? And you can see that it's going down here and going down there. In set A, the smallest proportion of data is at the mean. And increases as we get further from it. And then lastly, this final one, right? 5.43, 5.57. It's pretty close, right, in terms of the mean. Um, what would you guys say for this one? Well, I'm just going to tell you just for the sake of time. They basically have the same standard deviation. And here's the thing. The graphs are reflections of each other. Do you see that? Okay, so there, I think that's good. Um, we'll stop there for the sake of time. And you guys have your homework assignment, and we'll go from there.